Hey, welcome to the Explainer. Today, we're going to dig into something that is absolutely fundamental to network security, the AAA Framework. It's the system that basically acts as the bouncer and the hall monitor for your entire network. It controls who gets in and what they're allowed to touch once they're inside. So let's jump right in. So let's start with a big question. How do you really control who's doing what on your network? I'm not just talking about keeping the bad guys out. I mean, how do you manage every single thing a legitimate user, even your top admin, does?
For the longest time, the go-to method was just slapping a password on a router or a switch. It's like having one key that opens every door in the building. But what's the problem with that? Well, if you give that key to 10 people and one of them goes and reconfigures something that takes the whole network down, you have absolutely no way of knowing who did it. There's just zero accountability.
Okay, so the next logical step was creating individual user accounts on each and every device. That's a bit better for sure. But just imagine for a second you have a network with 500 routers. An employee leaves the company. Now what? You have to manually log in to 500 different devices just to delete their account. It is a complete and total management nightmare. It just doesn't scale.
This is exactly the problem that the AA framework was designed to solve. It gives you a structured, scalable solution that's built on three core pillars, and each pillar answers a very, very specific question.
So the first pillar, the first A, is authentication. This is the front door. This is the system looking at you and asking, who are you? And you have to prove it, right? You prove your identity with something you know, like a password, or something you are, like a fingerprint, or even something you have, like a little security token. It's all about verifying that you are who you say you are.
All right, so you've been authenticated. You're in the door. The next question is, what can you actually do here? And that's authorization. See, just because you're allowed in the building doesn't mean you get the keys to every single room. This pillar defines your permissions. So a junior tech might only be authorized to run basic show commands to check on things, while a senior engineer is allowed to actually configure interfaces. It's all about enforcing roles and privileges.
And that brings us to our final pillar, accounting. This one asks, what did you do? Think of this as the network's security camera system. It is always watching, always logging. It records every command that was typed, every resource that was accessed, and exactly how long a user was connected. If something breaks, the accounting logs are the first place you look to get the whole story. Who did what and when.
So we get the concept, but how does this actually work in the real world? Well, there are two main ways to set this up. You can do it locally, right there on the device itself, or you can use a centralized server. First, let's look at local AAA. As you can see here, the user connects straight to the router, and the router checks its own internal user database to see if they're allowed in. It's super simple for, one device in a lab, but it brings back all those scaling problems we talked about. It's just not practical for a real network. Now, this is the modern standard, server-based AAA. In this model, the router isn't the one making the decisions anymore. It's really just a middleman. When a user tries to connect, the router just forwards that request over to a dedicated central AAA server. That server has all the user accounts, all the policies, and it just tells the router yes or no.
And the benefits of doing it this way are huge. First off, you get centralized management. You can control your whole network from one spot. Second, it can plug into existing user databases, like Active Directory. That means you don't have to manage two separate sets of credentials for everyone. And finally, you get redundancy. You can have multiple AAA servers, so if one goes down, your network security doesn't skip a beat.
So when that router needs to talk to the AAA server, it has to speak a specific language, or a protocol. And in this world, there are two titans, two main players, TACAX Plus and Radius. And trust me, choosing between them is a really critical decision for any network architect.
On one side of the ring, you have TACAX Plus, which is a super powerful protocol that's heavily backed by Cisco. And on the other side, you've got Radius, which is an open standard, meaning pretty much every vendor out there supports it. So this isn't just about a technical feature list. It's a strategic choice about your network's future. This table really breaks down the key differences. So let's walk through this. First up, functionality. TACAX Plus keeps each of the three A's separate, which gives you a ton of flexibility. Radius, on the other hand, lumps authentication and authorization together. Now, transport. TACAX Plus uses TCP, which is reliable. It guarantees your security messages get delivered. Radius uses UDP, which is faster but less reliable. Okay, now for confidentiality, and this is a big one. TACAX Plus encrypts the entire body of the packet. Everything.
Radius only encrypts the user's password. But for network engineers, this next one is often the killer feature: customization. With TACACS Plus, you can authorize specific commands for each user. That's incredibly powerful. Radius just doesn't have an option for that. The one area where Radius clearly wins is in accounting, where its features are a lot more robust. Okay, so we've looked at the pillars, the architecture, the protocols. Let's tie this all together. Why is this stuff so incredibly important for anyone studying network security? Look, at the end of the day, having a proper server-based AAA framework isn't just a nice-to-have. It's absolutely non-negotiable in a modern network. It takes you from that chaotic device-by-device mess and gives you a single point of control. It seriously enhances your security with detailed permissions and encryption, and it finally gives you real, true accountability because you can log every single thing that happens. So I'll leave you with one last thing to chew on. As the whole industry moves towards this idea of zero trust, where we trust nothing by default and verify everything, which of the three A's, authentication, authorization, or accounting, which one do you think is the most critical to get absolutely perfect? It's something to think about. Thanks for watching.